So as Ash said, I'm Jarrod and this is Anthony, and we're both developers for KIXEYE Australia. And today we're going to give you guys a look into our game, VEGA Conflict. A few parts were a bit technical, so I hope people can follow along. And yeah, so to start with, we'll talk a little bit about the company. So KIXEYE is a San Francisco-based online gaming company that was founded in 2007. They did really well in the era of social Facebook games with Backyard Monsters, Battle Pirates, and War Commander. It was sort of compared as a more hardcore alternative to just the sea of Farmville clones that were around. If you haven't heard of any of these games, then you may have seen our recruitment video, which was around a few years ago. Now, KIXEYE Australia opened its doors in 2012. We're a team of about 40 people who came from Three Blokes Studio and Sega and Creative Assembly. And we work exclusively on VEGA Conflict. And as a little bit of a bonus, you might not be able to read it, but in the bottom left-hand corner, we've added some interesting user reviews for a bit of entertainment, and we'll talk about that a bit later. So to start with, this is the trailer that we have on Google Play at the moment. So hopefully this will play and have some kind of sound. Nope. There we go. Wow, that's amazing.
Way to sell it, Jarrod.
Okay, so after the huge success that KIXEYE had with a few of their games, especially Battle Pirates, they wanted to continue building on that same formula. So VEGA Conflict was kind of born out of the idea of doing Battle Pirates in space, but it very quickly grew into its own game and something much bigger. And now, about 3.5 years later, it's grown into a very large and very complex project. So the type of game that it is it's a cross-platform, free-to-play, massively multiplayer, online, real-time strategy game, which is a real mouthful. But it basically revolves around base building and real-time combat and social interactions. We're cross-platform, so you can play the game on PC with Steam, and then when you're on the go, you can switch to your mobile. It's all the same account. Combat's real-time, you have full control over all of your ships, and there is a lot of customization in it. And the last point is we're server authoritative, which we'll be talking about a fair bit. So coming out of that Facebook era of social games that I mentioned earlier, the standard approach was to provision some hardware in a data center somewhere or on some shared hosting service. And what you'd do is you'd have a PHP application sitting behind an Apache web server. You'd store your data in MySQL, and then on the front end, you'd have Flash sitting on Facebook or some other portal, and you're pretty much done and dusted. This setup came with a lot of restrictions. You could only really support limited interaction between players. There was no sense of a cohesive world, and because it was client authoritative, cheating became a real problem. And there's actually quite a few games that still use this setup or something very similar to it. And unfortunately, it didn't meet, well, not unfortunately, we did something much better, but it didn't meet our requirements, so we needed a much more robust architecture. Probably the most noticeable change was that very early on, we noticed that our market was shifting. Players were migrating to mobile, and it may not have been our web players that were migrating to mobile, but the mobile ecosystem was just becoming so big that it was really hard to ignore. And that combined with the rising cost of acquiring a user on Facebook, it meant that we needed to change something. So there was two things that we needed to do. First, we needed to go where our players were going, and we needed to be able to support all popular platforms. And that's because platforms come and go, and it can be very advantageous to not put all your eggs in one basket, and we needed to be able to do that. And so the thing that was clear was that Flash just wasn't going to cut it. We started looking for an alternative, and there's some listed up here. But it really came down to Adobe Air and Unity. And Air was a front runner because the game was originally built in Flash, and it meant that there wouldn't be a huge amount of code changes to actually port it, so it was the cheapest porting option. The problem with it was that it struggled performance-wise right from the get-go. So that was very risky. Unity, a lot of the office had actually used it before, and it had become very popular. It supported lots of platforms. It did mean that we'd have to convert all of our code into C#, and at the end of the day, we didn't really know how it would perform after we've done all that work. We did a fair bit of due diligence to actually make sure that it would be able to perform, and then at the end of the day, we bit the bullet and we ported over to Unity. This gave us an opportunity to start fresh and in some ways to start a new mess, but we won't go into that. And during the port, we managed to keep a lot of our architecture, and this was mostly, well, there's a few reasons for that. That was so that we could still use the same data and same assets, and also just for a little bit of speed so that everything was pretty similar when we moved across. And porting took several months, but at the same time, we still had this live game running. We were still doing updates. We were still putting features into Flash while we were actually building the Unity client. And we gave our players the option to use either. So there was a button on Facebook or KIXEYE Live that they could click and they could switch between them. We had a lot of early adopters actually go in and find things that were wrong and let us know, which was very helpful. And then once Unity hit parity, we cut off Flash completely, and that was a great day for us to not have to develop both at the same time. And even though we'd given out this shiny new Unity client, there were still a few people that wanted us to bring back Flash, as that little review down there. They weren't happy, but they grew to love it, I'm sure. So to do all these amazing things we wanted to give our players, we needed to be server authoritative. It was far more complex than the layout that I showed you just before, but it was also a lot more powerful, and it was well worth the investment. It also had the benefit that we were able to mitigate a lot of cheating that was happening in the client authoritative games. If a user wanted to hack our client, go for it. It's not going to help you. It's not going to give you kind of any competitive advantage. You might just make things look funny. So the next point is the cloud. So why did we choose the cloud? And it's important to note that we didn't start in the cloud for the first probably year of VEGA Conflict's life. We were on fixed hardware in a data center, and then we migrated, much like we migrated the client across. So why did we actually do this? Because it's not just for fun, we actually needed some hard reasons that we were going to make that effort. And so the first one was that it was much faster and easier to spin up more servers and environments, which we needed. And it was a lot cheaper, and that's even without taking advantage of any auto-scaling or stuff that these cloud services sort of promote as being able to make things cheaper. So even though we didn't do that, it was still a lot cheaper. It's a far more resilient environment, and there's still problems. There's still little network hitches and stuff that you deal with, probably more so than fixed hardware. But it's the big things that were a great improvement. So particularly DDoS attacks used to be a real problem, but since the migration, they've been barely a blip on our monitor, which has very much helped. And if there is a problem and we need to move to a different machine or something like that, it's quite quick to actually just reboot it or switch it to another instance, basically. And so part of this multiple environment thing that we run is that we develop more than one feature at a time. We have quite a few running in parallel, and we use perf or streams behind the scenes for that. And with each of these features, we need full testing in what we call a production-like environment, which is as close to the live game as we can get possible. And once it's been tested, we put it back into our mainstream, and at the end of the sprint, we release whatever's there, basically. But we need to be able to do them all at the same time, and some take a few months to do, some take a week to do, and this setup really allows us to do that. So it's not one big server. In the background, it's multiple applications, and as you'll see shortly, there's quite a few technologies involved in this. They're heterogeneous in nature, so they all have different specific jobs, and they talk to each other, and they make up the whole of the back end of VEGA Conflict. So we have applications for our bases, we have applications for our maps, we've got applications for our battles and heaps more. They all need to talk to each other. There's a lot of communication going on. And then each of these servers may or may not be distributed across multiple machines. And because of our setup, we actually have the freedom to be able to rearrange them as we need, which is very helpful. And the last point on this slide is one of the challenges that comes with the server authoritative architecture is that if the servers go down, then the game goes down. And that can be a real problem. That just means no one can play at all until you fix what's going on. Basically, we needed to make sure that we could handle a very high volume of concurrent users. And not only that, we actually had to estimate what our peak volume would be, and then we needed to cater for that, and then some threshold above it. So over the past couple of years, we've received multiple features from both Apple and Google, and that can really test this capacity. When this happens, it's not just a small increase over time, it's a burst all at once. And so basically you need to consider your regular user load plus some unknown quantity of promotional traffic on top of that. And you really don't want your servers going down during a promotion because that is very bad. So what do we actually do? I mentioned we didn't do this stuff before. So this is part of the technology stack that we use. There's a lot more going on, but these are sort of the main ones and the ones that we'll cover today. As we mentioned before, the game client runs on Unity, and it's sort of advertised as a run everywhere. It's got multiple platforms. It is getting quite mature, so there's a lot that you can do with it. It has good support. There's a really good community around it, and all of the editor tools are really good, and they're extensible. So if it doesn't do something you want, then you can add it pretty much. Servers still run on Linux. PHP has now been sort of delegated to more of a web interface or an admin tool, and it's a wrapper for our external APIs, basically. MySQL we're still using, but it's now been accompanied by MongoDB, and we use them both for different things. MySQL is very good at transactional or atomic operations, whereas Mongo is scalable and it's schemaless, which sort of means two things. You can have different records that don't have to match at all. They can have different structures and fields, and that's perfectly legal in MongoDB. You still technically have a scheme, but it's defined by your application rather than the database. So you have a bit more flexibility with how you want to handle that. We use MySQL for account details, so anything related to sort of the person. And we use Mongo for anything that is game related. So the player, the base, and that kind of thing. The next big one is Scala. So as I mentioned before, there's a lot of applications that are running in the background. Most of these are written in Scala. And it's a scalable language that runs on the JVM. So it's sort of advertised as a successor to Java in a few ways. It's a bit higher order than Java, and it has built-in concurrency models, and we use actors and clusters and stuff, which all really helps with the scaling of it. And then the last one that I'll mention shortly here is RabbitMQ, which we really need once we actually start growing a bit of scale. It's our communication bus that sits between a lot of applications, and it just basically manages load between them. So it's not just the communication from the game to the servers or from the servers to the database. There's also a lot of intercommunication going on between all of these applications. So we're cross-platform. Unity is this build once, run anywhere system. And I've put the point up there, kind of, because this may be true for small games, but as your project grows, this becomes less and less true. And to understand this, we really need to elaborate on what it means to be cross-platform, at least for us. What are the things that we consider when we move to a new platform? Now, there's the obvious things that most people talk about, and that's form factor and input types and device specs. But these aren't really a problem if you plan for them. So for example, we plan to have multiple different resolutions. So all of our UI caters for it, so that's not an issue. We abstract all of our input away from the game, so the game actually has no idea which platform it's running on most of the time, so that's not an issue. We scale our graphics quality and frame rate and all these kind of things based on your device specs and some other little variables, which means on desktop you get the full best visuals we can give you, and it's 60 frames a second, and then on the small budget phone you can still play, it's just lower quality visuals, and we drop you down to 30 frames a second. So that's not an issue either. So what are the actual issues? First is we don't consider a new platform necessarily as a new operating system. We look at the platform holders, such as these ones here, and this is the store that your application will be downloaded from, or the portal, such as Facebook, that you'll actually play the game on. And they each have their own rules and sort of guidelines to actually being on these platforms. So for example, payments, they usually dictate that payments are handled through their payment portal, which you've got to support that. So you move to a new platform, you've got to set that up. We handle all of our logins and authentication through these platforms. We allow users to log in with any of our supported social networks on all platforms, and to link between them, that kind of thing, except for Game Center, which only works on iOS. We grab people's friends lists so that they can do things like relocate to their friend's planet. We grab avatars so that you have a profile picture by default. And then they have all these other systems like leaderboards and achievements, which they're always trying to promote. So we were actually able to negotiate integrating these as part of the terms for a promotion. Originally, if we were going to implement these features, we were going to handle them ourselves, which meant they were completely cross-platform and we didn't have to do any platform-specific stuff for them. And plugins can be a big issue for cross-platform. For example, the Facebook Unity plugin only supports Android and iOS. So when we moved to Steam, for example, we still wanted our users to be able to log in with Facebook. So we did this with a combination of a web view and OAuth 2, and we got that all working. But we'll talk more about plugins on a later slide. So you've probably noticed that I've got a little section here about web player. And why is that? Because web player is disappearing. The Unity web player is really on its last leg. With browsers dropping MP API, which is what the web player runs on, they can't really support it anymore. And I think they're actually removing it in a future version, but I'm not entirely sure. Despite this, I thought it'd be a really good way to illustrate this next point, in that when we say we support web player, it's not just one platform in a way. We support Firefox, Chrome, Internet Explorer, Safari, etc., etc. And that's on both Windows and Mac, and that's on both Facebook and on our own KIXEYE Live platform. So if there's any problems anywhere, there's a lot of places for it to hide, basically. And we'll run quickly through the other platforms. Just a few notes on each of them. So when we look at Mac OS X and Windows, we've noticed that OS X tends to be more up to date. So you have users on primarily on one version rather than across the board. Whereas Windows, they come from many different versions. They tend to wait to update for a while. So you do have to deal with that variety. I don't know what our oldest version of Windows that we support is anymore, but it's pretty old. So Android, everyone knows there's a lot of variation in Android. There's countless devices, so many manufacturers. It's not just resolutions you have to deal with, but different versions and firmware and CPUs and GPUs and architectures. You've got ARM and you've got x86. You could have a good CPU and a rubbish GPU, or the other way around, or they're really good, or they're both terrible, and it can really be anything. But we're not picking on Android, because iOS is not perfect by any means. It used to be you'd develop for iOS and you'd deal with sort of one resolution and that was it and everyone was very happy. Whereas this is becoming less and less true with each new release. They're adding all these crazy screen sizes to it. And And I'm not sure if it's still an issue, but when they brought out Retina, you had to deal with the point-to-pixel ratio, which kind of complicated things even further. There's problems with different versions of iOS, and this is not specific to iOS, but for example, you could have like a 2014 iPad mini with iOS 8.4.3, and there's an issue, a really bad issue that only exists there and absolutely nowhere else, but there's heaps of users on that. So you've got to fix it, unfortunately. Like OS X, they're really aggressive to update, so you don't have as much of a breadth of versions to deal with. But saying that they move forward with their APIs quite quickly, which actually means that you can be developing on there, and your code actually gets deprecated while you're working on it, essentially. We had code, Objective-C code that we wrote a year or two ago, and because of this fast updating, it's already marked as deprecated. So you go into Xcode, and there's warnings everywhere. And at some point, we're going to have to fix this. So it's something to look out for, basically. We experience more memory issues on iPad. This is mostly true because our min spec is iPad 2, which only has 512 mega RAM. Whereas on Android, we actually dictate that you must have 1 gig of RAM to be able to download the game. So Android has a bit better, it's easier to set hardware limitations on that platform. So what does that actually mean in practice? It means there's a lot of places for bugs to hide. You end up with platform-specific code all over the place. At a time, we had lots of different duplicates of UI to support different screen sizes. Anthony will talk more about that a bit later. And basically it means a lot of testing. So I've taken a picture of a couple of our devices. There's plenty more scattered around the office. So just a bit of a shout out to QA because they have to deal with all this rubbish. Okay, third parties. So I went through our project and I tried to find all the source third parties that I could. These are the ones that I came up with. I've probably missed some, and I apologize to those third parties. But basically what you can see here is that there's a lot of dependencies going on. And one very important thing that we've learned about third parties is that they suck. And that might be a bit too aggressive. So the points that I'm making on this slide are mostly targeted at the client APIs. And this is purely, I think, because they're a bit newer and they're Unity specific, whereas the server-side ones, they're used by a broader range of people over a longer period of time. So other people have sort of sorted out a lot of the issues that there are there. But I'm sure there's still issues all over the place. So why are they bad? What do I mean by that? Basically, there's problems in all of them. Some are small problems, some are big problems, some you'll never have to deal with, and some can be showstoppers, basically. Quite a few times, we've actually found these issues. We've fixed them ourselves. We've pushed them back to the third party, and they've released them in updates, which is quite cool. A lot of them are willing to do something like that and work with you. And quite a few of them make the assumption that they're the only plugin. This is especially true on Android, where everyone wants to extend the Unity player activity. And this is because Unity actually tells you to do that in their documentation, which works fine if you're the only plugin, but as soon as you add a second, it just breaks down completely. They're getting a bit more wise to this now, and a lot of them are fixing this, or we're fixing it for them. But if they haven't, then an option is to get a source license and change it around yourself. But that can be a bit complicated. And quite a few of them assume a standard or manual build pipeline, mostly because they're targeted at indie developers, whereas we automate almost everything. For example, one of these plugins said, drop it into Unity and then export an Xcode project, link these libraries, change these settings, build. Whereas we have to make sure that can all be done through script. So we drive the Unity editor through the command line, which generates the project. And then we have all these tools that do the modifications to the project. And then we spit out a bunch of things at the end. So to summarize this slide, the first plugin integration is usually easy and more become more difficult. And the more complex your project becomes, the more important it is to have processes and to automate this kind of thing, because it can become really easy to make mistakes when you're doing things manually. And if you have the option to go for battle-tested plugins that other people have found all the problems in and they've been fixed, and ones that are being actively supported as well, because new versions are coming in for absolutely everything all of the time, you need to make sure that they're going to be around for a while and it's going to be easy for you to update. So now I'm going to pass it on to Anthony for a little while, and I'm going to stop talking.
So I thought I would start with a... Oh, yeah, true.
Yes, told you I'd forget.
Yep. I'll figure this out eventually. All right. So I thought I would start by giving a brief breakdown of how we might actually build a feature when we're working on something for the game. So as Jarrod mentioned earlier, our features are built. We're running a live game here. So we need to ensure that every feature we make is stable, secure, and of a certain level of quality. So it helps to have some sort of workflow that we try to adhere to as much as possible in order to facilitate that quality and stability. So I thought I'd give a quick rundown of an example of how we might build a feature. So the first step we generally start with is a brief. And this is a short written document written by the designers. And that tends to explain the basic task and expected outcomes of that task. They're very short, and it's just used as a guideline, so we can then frame the next step, which is the spec, which is essentially a fleshing out of that original brief. Design will often consult with relevant parties, so artists, programmers, to get an idea of scope so that they can frame how much or how large this feature might end up being. They're longer, and they generally contain things like a full feature breakdown, including any data formats that might need to be defined from passing from one system to another, any requirements for completion, and if there's any UI, at this point we'll add UI wireframes so we can get an idea of how this thing might actually work in the game. These specs tend to be very iterative, so we work together, we modify things, we add comments, and that's why we use Google Docs for these first two steps, because when you're working on an iterative or a collaborative document, it's pretty fantastic for something like that. We also have what we call a roadmap document, which is essentially a list of these completed briefs and specs that are sorted based on priorities and goals for the particular quarter. And that's also managed via Google Docs. So after the spec, we tend to have what's called a kickoff meeting, where the relevant parties will get together with the designers and discuss the feature, and that's a further iteration of that spec. We determine risk at this point, estimate times, and assign any tasks if they're required. And we use Jira for our task tracking, which is incredibly useful. So we'll often assign a feature, an epic task, and then sub-break it down into subtasks and distribute that amongst the people who are developing the feature. We often at this time will also take time to add QA tasks as well, because it's very important to have QA involved in the process as early as possible to ensure that they're fully versed in what the feature might be and what it's going to become and as it evolves. So we'll actually have QA features added, QA tasks added at that time as well. Usually things like to develop a set of acceptance criteria which they can then use to plan their tests when they're signing off the feature at the end. So after the kickoff, we start development. So during development, we'll often lock a feature behind what we call a game flag, and you can see that listed at the end there. And a game flag allows us to essentially toggle a feature on or off. This is done for a few reasons. We try and keep our well, it's done for a few reasons. So for starters, IOS certification can often take weeks. It's a mystery box, right? So if a feature requires a client update, we have to wait for all users to have that client before we can actually release that feature. So we'll often bundle into a specific release a lot of content that's not available initially, and then we can unlock that content at a later date. We have a monthly release cycle, so we need to bundle as much as we can into that monthly release, and then we can unlock that at stages throughout the month so that our players have content throughout the month rather than just a single burst at the start. And we also have to make sure during this development phase that all the features we make need to be backwards compatible, because we can't always guarantee that the iOS and Android client users are going to be running the latest version of the game. We can force a min version bump at some point, but once again, we have to wait for that iOS certification before we can actually achieve that. So we use Perforce for version control and stream management, which I think Jarrod mentioned before. So every feature will get its own feature stream. We branch off the mainstream. So essentially, we start with a snapshot of main, and then we work in isolation away from the mainstream. We keep main as a sort of rolling release candidate. It needs to be ready to be released at any moment. If for some reason a feature got delayed or didn't get finished in time, we don't want it polluting the mainstream if it's in a state that's not fit to go out. So all features are developed in isolation, and then developed in isolation in their own streams. So after the development, we move on to the testing phase. At some point, the developers will say that the build is in what we call a buggable state. And at that point, QA will start investigating and start testing. So they'll run through their test suites that they've developed. They'll do some exploratory testing if they have time, backwards compatibility testing. And if it's a large feature that requires some new back-end stuff, we'll do load testing as well. And they'll report any bugs to the developers, and they'll get fixed, and we'll just keep iterating on that process until QA are happy. Once QA are happy, the build is marked as signed off, and we can integrate that stream back into the mainstream again. And then we have our releases. Once a month, as I said, we have a release candidate. The release candidate is branched off the current mainstream. QA will then perform their tests on that release candidate to make sure it's ready for release. And then we'll do our monthly release where we release new server, a new web player, we'll upload a Steam build, we'll upload an Android build, and we'll submit the iOS build for certification. Currently, there is a little bit of downtime when we do these builds, but we're working towards minimizing that downtime as much as possible. And then, as I said earlier, we've then got the game flag at the end. So once all the clients are up to date, we can then switch on the game flag and players can get the feature. So for those actually unfamiliar with Vega, I'm about to start talking about some gameplay and UI stuff. So I thought I'd give a very quick breakdown on what Vega is. Jarrod covered on it very briefly at the beginning, but I thought I'd just give a little bit more in depth here. So Vega is one large game world. The game world is broken into galaxies, sectors, and planets. So the galaxy is made up of sectors. Every sector has a series of planets, and then every sector has planets. Players have a home base located on a planet, and players can move around those planets and sectors using their fleets in real time with other players. And we also have AI-controlled fleets that patrol those planets and sectors as well to give a non-human target if players want to participate in PvE instead of PvP combat. In terms of social interaction, we have real-time chat. And we have what we call alliances. We're essentially clans. So it allows players to work together, protect each other from enemies, help with processes. So fellow alliance members can help you with one of your current build processes if that's the sort of thing that you need. And so it's actually quite beneficial to be in an alliance. Real-time combat is 1v1 with fleets of 6 fleets on each. So you can control ships, you control their movement, position, rotation, targeting, but we also have certain levels of AI control if you don't really want to be so granular, if you don't want that level of micromanagement. So you can essentially leave it up to the AI if you wish. So we have player versus player combat, player versus base, so you can attack other players' bases, and then as I said before, you can attack AI targets as well. And in terms of features, I mean, we've got heaps of features. We've got loot drops from combat. We've got a crafting system, research dialogues. Ships themselves are equipped with equipment that the player chooses, so they can equip components, weapons, armor onto their ships and build their own custom fleets. And that goes the same for base building. You can equip components and weapons there as well. We have what we call events, which are essentially high-volume fleet events where players will go out, attack a target, they gain points for that target, and then they can use those points to claim prizes at the end of the event. So we actually have one of those events running live on the game right now. And then all of this is available on every platform. We don't remove features for one platform. If you can do it on one, you can do it on any platform. And it's the same account on multiple devices, as Jarrod said, cross-platform. And the other thing that's important is that because it's cross-platform and because it's the same world, all players are in the same game world. You've got iOS, Android, Web, Steam. Everybody is all playing in the same game world. The UI and inputs are adjusted for those, so that the thing that's important is that whatever platform you're playing on, it feels like it was designed for that platform, and that's what we try and achieve. So I thought I'd give a breakdown on user interface, and I suppose it's because user interface is probably the biggest difference between the platforms. So porting Vega to Unity was an interesting challenge. We started with all of these existing assets from the Flash game, and we wanted to use as many of them as we can. But at the same time, we had this opportunity to redo a lot. But we didn't just want to redo things for the sake of redoing them. As much as we could, we ported things like the graphics and the effects pipeline and those sorts of things. But we realized at the beginning that our existing UI system probably wasn't going to cut it, and we were going to need to do something new. So what we were using previously was an in-house system which we called descriptors, which are essentially text-based JSON files that described UI elements. They were used for not just UI, object states and other things also used this. It was fairly widespread and used throughout the game. They had an incredibly steep learning curve, and they were quite difficult to maintain. And every time you edited one of these, it required a rebuild of the game. So that was, not a huge amount of time, 1 to 2 minutes, but it was enough when you're iterating on a dialogue that it was actually quite time-consuming. So the opportunity to switch to prefabs, I think, made our UI artist very happy. So he could now work in a, what you see is what you get editor, build the dialogues as quickly as he can, and allowed for this really rapid, fast iteration time. So we actually use NGUI for our UI. At the time, it was the best available option. UGUI wasn't out. It was just a mumbling in the distance. So we obviously could have written our own, but we had this existing system, so we opted to use that. So we've got desktop and handheld variants of almost every dialogue in the game. So we didn't want our mobile game to just be a simple reskin of the web. It wouldn't work, right? You need to make sure the input is platform appropriate, and you need to make sure that UI and font sizes are positioned correctly and appropriate for the device that you're using. So this meant that, every dialogue was probably going to be created twice. Fortunately, that faster iteration process that I mentioned earlier was a massive bonus. And it made prototyping things significantly faster. I remember when we were first switching to Unity, I must have done the ship factory dialogue about 7 times in the space of about 2 weeks. And that's not something we would have been able to do using the previous system. So you can see here we've actually got, this is the same dialogue running on 2 platforms. You've got the web version of the research dialogue on the left, and you've got the handheld version on the right. And these dialogues perform exactly the same function. But they're styled in a way to ensure that it's a native experience on the device you're using. So on desktop, it's mouse controlled. You use the scroll wheel. There are hover effects when you hover over items. We use a smaller font. We tend to lock our windows to a fixed size. And we found that our desktop players prefer smaller buttons and an unobtrusive UI. They want to, if they're using a high resolution display, they want to have as much game as possible and keep the UI, out of the way. Whereas handheld is touch controlled, so it's gestures, swipes, and pinch zooms instead of scroll bars and scroll wheels. The buttons are larger, fonts are larger. And all of our handheld dialogues are designed to react to screen size. So we use the NGUI anchoring system to ensure that our dialogues fit to full screen and they scale appropriately. They also need to handle platform-specific behaviors. So things like the Android back button is incredibly important. As Jarrod mentioned before, with integrating Google achievements in order to get featured, integrating things like the Android back button is essential. You make sure that it feels appropriate for the platform you're working on. And then there's other things like the feature images for icons are larger and more showy. Another thing is we move towards more icon-based UI and less text. So there's less information primarily on the handheld one. And a lot of the secondary secondary information is available on request. So we display players important information up front, and if they want to establish more or find more information, they can go looking for that. NGUI is used for, sorry, I skipped a bit. Dialogs are created for appropriate platforms, and we have a UI manager that handles spawning of dialogues, so things like what dialogue will appear at what depth, priorities of dialogues, is this dialogue more important than the other? We make a request to the UI manager, and then the UI manager says, what platform are you on, and is there a dialogue that I should be using instead of this one? So it allows us, for the most part, we just use web or desktop and handheld, but it does allow us a level of granularity where we can actually have very specific dialogue. So an iOS phone dialogue, for instance, we could have a very specific version for that if we wish. So NGUI is used for most of our in-game UI. All our dialogues are UI. We use an in-house system for usually objects that attract to in-game items, so text, names on player fleets or health bars and things like that, and that's just for performance reasons. So one of the downsides to using prefabs is handling merges. So if two people are editing the same prefab in two different streams, you're probably going to end up with a merge conflict, and that's going to cause a lot of problems. Even just rearranging the hierarchy, moving one component above another is enough to completely to cause huge problems. So we try and avoid it entirely if possible. We use a very high-tech piece of equipment called the prefab checkout spreadsheet, which we just list what prefabs we're working on in what streams, and it helps. If you need to make a change, you go to the stream that the prefab is being worked in, and then once that's come back to main, you're free to use it. So it doesn't mean that you can't work on prefabs if it's in another stream. You just got to be smart about it. You've got to be careful. All of our dialogues go through performance testing. We've got a UI verifier tool that we run that checks for things like draw calls, UI anchor update orders, and UI anchor update times. So NGUI has anchors that can potentially run every frame, and if you've got a lot of those, that can be pretty expensive. And the other thing that's fairly important, and one thing that's been great with Unity is our UI is full of custom components. All the UI, as much as we can, is designed for reuse, so we don't have to constantly recreate these things. I mean, we've got these two dialogues are essentially just a component. Like the dialogue on the left is what we call a context switch dialogue, where you select an item on the left and it updates a panel on the right, and that's all component-based. Same with the dialogue on the right. That's a scrolling card dialogue, and it's designed to be, depends on what the data you give it, but it handles that sort of stuff automatically. And a lot of the custom components are for performance reasons as well. So a big one is NGUI tables are fairly inefficient. If you've got 300 items, it'll put 300 items in that table, which is going to run pretty terribly. So we've actually got dynamic tables which will use pooled rows. So as you scroll, it'll recycle rows and only create as many as it needs. And most of these components are what we call context components, which I will explain now. So context is our game data collection. We use it for data binding, and I like to think of it sort of at the heart of the client. It's incredibly important, and almost every dialogue in the game uses it, as well as things like updating the states of objects and things like that. You can sort of think of it like a tree-like structure of data, which you can navigate using a dot notation. I suppose two main elements of context are the objects. So we have an objects context, which is the statically defined data. So this is the data that's defined by our designers before the game is built. Things like definitions of ships, names and mass and things like that, or weapon damage. And then we have what's called the instances. And the instances are dynamic states of objects. And the instance data comes from the server. And that contains things like what equipment you have on a ship, where a module is located, the location of a fleet on the meta map, something like that. And as I said, this information is sent from the server. So it's that server authoritative language platform that we were talking about earlier. It's incredibly important. The server tells the client this information. It's written to this instance context data, and then our UI will react to that information automatically. We can write other things to context as well. It doesn't have to come directly from the server. We've got things like current state of certain areas, so what dialogue is currently open, what state a certain object might be in. And another thing that we store 100% in context is our localized text. So I'll get to localization in a little bit, but our game is localized in 12 languages. So every piece of text in the game is localized. So yeah, context is used to display information about items, and you can bind to a value in context and get notified when that item updates. So things like this, the health of a fleet on sector view. So changing the icon from a normal to a damaged icon if the health is 0, that process is all handled automatically by changing a context value. The context menu, which is the dialog that appears at the bottom of the screen when you select a ship and it displays information about that object, is entirely populated by context. The vast majority of our UI, text, buttons, information about objects, it controls everything. So the ship factory is a good example as well. The ship in the center of the screen is an instance object. The server says you are editing this ship, it has these components on it. The list on the on the left-hand side is a list of weapons that is defined by these slots that are set up on that ship. The list on the right-hand side are the stats of the item you have selected on the left. And in order to handle this sort of dynamically updating UI, we've got a variety of components that help us. We've got path components, which help us set up that hierarchy for resolving these things. We've got conditionals, so we can change a sprite, we can change text, we can change color based on a context state. We can change textures, enable, disable objects, labels, progress bars, stats list. We have so many context components in, but it really helps make these dialogues feel more modular, you know, and it helps our UI artist as well, because he can often put together a dialogue without any help from one of the programmers. And it also allows reuse, as I said earlier. So we're not bound to any specific dialogue code. Once you've hooked up events on buttons and things like that and populated the data that you need the dialogue to react to, the actual dialogue itself can be pieced together fairly quickly. There's a lot of information. I could talk about the context system all day. I'm not going to go into any more now, but come have a chat to me later if you're interested. So localization, we are in 12 languages. So that's English, French, Italian, Spanish, Korean, Japanese, Chinese simplified and traditional, Turkish, Russian, German, and Portuguese. I think that's 12. So text is locally stored as separate JSON files. Those JSON files are combined into a single one at build time for each language. And they're just key values. It's as simple as that. And we have one text file per language, one of those large files per language, and that's downloaded on demand when the user selects a language and written into the context data. And obviously, because we're cross-platform and server authoritative, if you select your language in one platform, that language will be remembered when you switch to another platform. We use a platform called Transifex to manage our game text. Our localizers perform translations there. And Transifex is pretty useful. It can help manage things like it alerts you to any text that's remained untranslated or has been modified. It's got a history and glossary and suggestion, so it'll suggest translations for something that might have been translated similarly in the past. And it also allows for translation reviews, so you can get your translations looked at to determine the quality of translation and whether or not you need to readdress things. I say it's got all these features, but a lot of the time I find that our translators will actually do their translations in Excel spreadsheets instead of using the tool itself, which comes with a host of problems, which I'll mention in a second. So the basic process for us, we localize every week. So every Thursday we send off our localization text to get translated, and we download it again on every Monday. The process is scripted. When we do the upload, the first thing we do is actually download the current translation files. I know that sounds strange, but we do that to determine the difference between the two files, to see what has changed, just to confirm that what we're uploading is exactly what we want. And then when we download, we perform some error checking, validation, things like ensuring that any variables we have in our localized strings have been untranslated, because they often will get copy-pasted from the wrong location, so the key will be wrong, or there'll be a space in there. So we have some automated validation checks to ensure that those get looked at. Other things like invalid characters. As I said before, if you import into Excel, Excel likes adding random characters to things, changing quote marks into a strange double quote, or putting double spaces in. So we have checks to make sure we catch all of those. And then localization QA we have every Tuesday. So they're usually targeted sessions because we know what strings have come down, we know what's been translated recently, and our localization QA can actually take a look at that sort of stuff and determine what needs to be checked. In addition to the static text, we've actually got real-time chat translation in our in-game chat. So the chat translation, so you can see it running there, depending on what language you've selected on the client, it will translate any foreign text into your language for you automatically. And you can turn that on and off if you like, but it's incredibly useful being able to, I mean, we're a social game, it's live, we've got people interacting, and being able to communicate with every person in your server is incredibly important. And we use Bing for chat translations for that, and that tends to work fairly well. One other thing to remember when you're handling localization is fonts and UI and how you're going to handle this. So 12 languages, that's a lot of characters. We actually use Unity's dynamic fonts to handle text in the game. We have one font embedded in the game, and then the rest we use the dynamic fonts, and we have a very strict system font fallback list. So we use Unity's fallback list, and then we have our own as well. And that's because we've had some issues in the past. Running with dynamic text, you're going to potentially run into the situation where a user may not have one of your selected fonts on their device, and then they end up with no text. So you need to try and cater for that. You need to try and prepare for it. So things like in iOS and Android versions upgrading, they may change one of their system fonts or remove it. Or custom Android flavors not having the default Android fonts bundled with them. Unity does actually have, as I said, a font fallback list inside itself, but it's not always as up-to-date as you'd like it to be. So we had, what are the other choices? We had the choice of embedding the fonts in the game. It's not exactly the best solution, considering Chinese fonts can be upwards of 16 megabytes, and we need to keep our download size down as much as possible. And the same goes for bitmap fonts. It would just be too large. And the thing that makes a lot of this difficult is our live chat, because we don't necessarily know what language people might be chatting in. We don't know the total character set that might be available. So the dynamic fonts has actually worked quite well for us, with a few minor issues that we've resolved as they've come along. Few UI things to remember. You have to keep in mind that the English text that you've designed to perfectly fit into your UI might be different once you translate into Russian and you've now got 4 words instead of 1. You also need to make sure that it's best in that case to work with your translators, see if they can come up with an abbreviation, something like that. Avoid plurals and masculine and feminine if you can. Just because it works in English doesn't mean it's going to work in Portuguese. I'm pretty sure in Portuguese % signs come before numbers instead of after them. So there's all sorts of situations like that where you need to cater for those situations. And then also make sure that your variables don't get translated, because that can break things. And I think I'm handing back to Jarrod for this one. Yeah.
Yep. Okay, so we've been doing this thing for 3.5 years, but what have we actually learned from it, and what can we share with you guys today? The first note is that third parties suck, and I've discussed the reasons why over there. The next point is the iOS submission process, which Anthony talked about briefly. It can be anywhere between like a couple of days and a month, and they don't really tell you how much it'll be. In our experience, it's about a week in general. To get everything pushed through. If you do need to get something released quicker, so say you do an update with a game-breaking bug and you need to get a patch out immediately, Apple does allow for expedited releases, but they limit how many you can use, and it's sort of up to their discretion when they let you use them. So it's a handy thing to know about, but I wouldn't bank on it either, because they could just say no. And the takeaway from this point is, if you have the option, do Android first. And that's simply because it's a fast iteration time. You put an update to the Google Play Store, and within a couple of hours, your users can download it, which is fantastic. Then we go to networking is an interesting beast. And there are certain issues that you won't see at all until you hit scale. And a lot of these you won't be able to reproduce, and it could happen anywhere from the client to your code to somewhere in the network to on the servers, and they can be very hard to narrow down. So off the top of my head, I put down a few examples of random things that we found, and maybe they'll help. They may be fixed now, they may have changed, but these are things that we came across during development. So if you're in the US and you're on Verizon, they don't allow non-HTTP traffic on port 80, which kind of makes sense, but we use that port as a backup, and that's to get around firewalls. So if someone's playing on a network and they've got a firewall, they may still be able to play the game, which is quite handy, but this was a problem that we couldn't reproduce because we don't have Verizon here. So we actually needed the US to tell us that they couldn't play for some reason. And we managed to track it down to that. And then a little closer to home with our telecoms, and we found this on Telstra specifically, but I'm sure it happens on absolutely every network, is if you have a prepaid SIM in a device and you've run out of credit or data, then they still let some network traffic through, which can really make things confusing. So we'll get logs back that will say, yes, the user had internet, but no, they cannot connect to our servers at all, which was very fun to sort of figure out eventually. And then you have to be careful of public Wi-Fi networks, and particularly because, say you jump on the train and you have to go to their landing page and accept their terms and conditions before you can actually use their internet. But this means if they've opened your game before they've accepted these, any network response is just going to return their landing page. And again, some traffic might get through. So it might say, yes, you've got internet, everything's great, and for some reason they can't connect. And originally we were having a lot of issues with DNS. These may have been resolved. They may have been attributed to the reasons that I just mentioned, but it was something to look out for, because we sort of assumed that, yes, you can always resolve a host name, but that's not always the case. Sometimes it just can't do it at all. Which leads on to the next point, which is log everything. And I don't just mean some things, I mean absolutely everything that's going to be helpful for you to debug a problem. We don't use the Unity default logger, which is the standard debug.log. Mostly because it's really slow, but also we want to have it outside of the editor and always be able to get logs. So we use a file logger that just writes to the device what's going on. We also use something called SOS, which is a socket server, and you just throw stuff at it basically over TCP, and it prints out a log for you. And this is probably the biggest one that we use in development, because you can deploy to your devices and you can still have logs running on your computer, which is great. And the last one I've listed here is Hockey App. So we use it for our development distribution when we do new builds, but also we send logs to it, and they come through as crash reports, but they're not necessarily crashes. They're just, we send a special message to them and they list it down. And this has great features, so we can see how many of each problem users are getting, so we can rank them in terms of, okay, this one's really important because everyone's getting it. That helps us focus on which ones need to be fixed. And it helps us find out issues that we can't reproduce and we've never actually seen. So like I said, a lot of the network ones we don't actually see, we don't get them in the office, but this tells us that they're happening. It tells us how often they're happening. And then because we don't know how to reproduce them, we don't necessarily know how to fix them. We think we know, but until we actually do a new build and push it out there, we can't tell. And the way we figure it out is we look and see if they're still coming through. And if they're stopped, then we're pretty happy that we've fixed it and we've just lost a screen for some reason. And we're back. And then we move on to everything will change. So in the beginning, we were just a web game. We weren't expecting to move to so many platforms. There might be still more to come. I don't know. We just don't know what's going to happen in the future. Features will change, sometimes while you're working on them. Your players will want things. Sometimes we give it to them if it's in the best interest of the game, and sometimes we're already working on stuff. Players will hate things. You'll put out a feature, and there's always going to be someone who doesn't like it. You've just kind of got to deal with that. And it's all about this constant iteration and this agile methodology and just continuously improving what you've got, because you really don't know what the end target is until you start actually working on things. And then the last issue is to take user reviews with a grain of salt. I don't know if you could read them in the bottom corner, but they've been on each slide. Some are funny, some are mean, some are very mean. Some make absolutely no sense at all, but excluding sort of the trolls, like they're still your users that are posting, and they're taking some time out of their day to write a forum post or a review. And so even if they're angry about something, it's very important to try and figure out what it is they actually don't like. And oftentimes what they're saying and what they mean don't actually match. So it can be very helpful to try and dig in there and figure out what they're actually trying to say. And I've added, I don't know if you can read that from here, but this user left a review for us the other day on Steam. They gave us a thumbs up, but they didn't really know what to say, so they left us a chicken taco recipe, which we haven't made yet, but I'm sure we'll get around to it. So, And back to Anthony for a moment.
Home stretch.
We're almost there.
So, how are we doing? How are we doing? Pretty good. We're worldwide on iOS, Android, and web and Steam. Reviews are generally favorable on most of the platforms. And we've had features on a few of the platforms as well. Our user base is healthy and growing. And even web, with Chrome removing Unity support, we're still seeing active players. It's
Tells you user numbers?
Nope.
No. We've got new content improvements events regularly. There's events I talked about earlier. We've got one running right now. Plenty more content and features on the horizon. Not that I can talk about them, but plenty more to come. And so yeah, what is to come? The technology stack is always improving. That investment in architecture and that investment in processes that helped us port from Flash into Unity, we're going to continue investing in that. We're going to continue to change and iterate and evolve, and that's what allows us to pivot so quickly and switch from one thing to another, if whatever we need to do. We're open to launching on more platforms. We're investigating replacements for web, but I think none of the current solutions at the moment solve the problems that we're seeing with things like WebGL. So maybe in a while they'll be mature enough for us to use those as a replacement, but for the meantime we're still looking. There's a move towards more real-time tuning, so the ability for us to tune a whole bunch of data from the admin panel, and we've got a lot of that at the moment, but we're making that a sort of a core philosophy of a lot of our design features at the moment, that the data should be tunable, as much as possible. And then yeah, we've got more features, more events, and yeah, just continuing on. And I think that's it. That was a lot, but thank you very much for listening. If anyone has any questions.
Can you talk about the onboarding process for new users? And also, it's like two questions in one. Also, if you can talk about retention and engagement, how you track the engagement of users.
You want to talk about that stuff?
Try and cover that. So we have various marketing channels that we use. We do a lot of advertising. And in terms of retention, it's really to, first of all, make a good game. But also we do sneaky things like send notifications and stuff like that to bring them back. But all very much standard practices in a lot of ways. Yeah.
But the onboarding for new users, is that a process that you guys track like closely or like iterate on?
Yeah, so we monitor incoming users, and actually it's to check whether our marketing's working basically and see, is this campaign performing better than this one, and then we sort of A/B test that kind of thing.
It's strictly logged, so yeah, we're aware of what works and what doesn't, and we can change.
Yeah, analytics are a very important part of what we do to actually figure out what's really going on in a lot of systems. So, yeah.
Yes.
Go here first.
Even though you use NGUI,
Yes.
is there a consensus of how UGUI is?
I've used it. I quite like it personally. I've used it a little bit for some work on done in my spare time. It does. There are certain things that NGUI does that UGUI doesn't do. NGUI allows you to anchor an object off any object. It doesn't have to be, whereas UGUI has to be the one directly under it in the hierarchy. But I think it sounds like NGUI would be more flexible, but I'm sure you could work around that with UGUI. I haven't used it a huge amount, but so far it seems pretty performant. It seems pretty good. I think it's pretty. I think it's good. Yeah.
To add to that point, we've also sort of invested in extending Unity a fair bit as well. So we'd have to redo all that stuff in
NGUI.
Yes.
Yeah, yeah. So yeah, if we were to ever switch, we would have a lot to bring across. Yeah.
Yep. Okay, cool. We have one over there.
Thanks. So you use the web player, so that allows the user to download the actual file for the game?
No, so it allows them to play in the browser on Facebook and our own portal, KIXEYE Live.
The only way to play the standalone game at the moment is through Steam.
Yes.
So web you're playing in the browser, whereas if you wanted to play in a standalone application, you'd get the game on Steam.
So, but if someone downloads the file from the web player and takes that and doesn't,
doesn't go through the web platform.
Yes. So we restrict that actually. If you're not playing on the platform that we support, then there's certain bits of code that just won't run, basically, and that's just a restriction that happened as the way we've actually built it up.
The JavaScript layer around web platform provides a lot of integration with the social platform. So if the JavaScript layer is not there, the game won't run.
Yes.
Thanks, Alan.
Can I ask a question about like monetization or is that?
Depends on what the question is.
Yeah, we'll give it a go.
I was just going to ask, like, do you, from experience, like, would you think it's best to build the game around monetization around the game? Like,
We want the game to be fun.
Yeah. It really depends which department you ask, but
Yeah.
you sort of need a combination of both. You need to, like Anthony said, you need to build a great game, but you also need to make sure that there's a way that you can monetize it eventually.
It's a business, right? You need to make money.
But at the end of the game, if you make at the end of the day, if you make a rubbish game, then it doesn't matter how good your monetization is because no one's going to be playing, so no one's going to be buying. You have no customers then. So, yeah.
Hey, do you feel like your in-game community, because it is like all around the world and everything like that, do you find it's like quite positive, and what do you do to make sure that the community is always kind of going in the right direction for the game?
Yeah, I mean, our community is, I think, generally fairly positive. There are moments of outrage, you know, because, as I said, the game's constantly changing. We make modifications a lot, and the players don't always see those modifications as good. It's a change, and change is bad. But given a week or two, they see the reason behind it, and you know, and I think we work with our players as much as possible. We've got a series of trusted testers that we'll communicate with and discuss early features with, and we've got a series of community managers who help manage that as well. But they create some great things. We've got one guy, every time we've got an event, he'll post a video which will explain the breakdown of the ships and how to tackle this particular one, and it's great seeing that sort of stuff. It's really great, yeah.
How do you balance the fact that there are people that have been in the game for say 5 years, so they probably have a lot of coins or better ships, and then new players come in and they don't have, they can't reach the same level? How do you keep those?
We've got series of level gating, so depending on the level of your fleet, you can only attack a fleet within a certain level, and at the same time, we've got. We encourage people to join alliances, and in alliances you'll find that the larger members will actually protect the smaller members and help them get up to that level. But yeah, we do have a level, so high-level players, if they want to attack a low-level player, they need to use a low-level fleet. So, yeah.
So, curious how you approach the PvP networking?
So, because it's server authoritative, everything runs on the server, and then the client just basically simulates what's going on. So there's actually no logic being done on the client. And so the application in the cloud just runs it, and then just through a TCP connection, it just sends updates and deltas and stuff like that. So, yeah.
And
Yep.
just to add to that, we didn't do PvP networking. So I don't
Yes.
think you can reliably accept connections on mobile. So all traffic goes to the contact server.
How do you deal when if you're in the middle of a real-time battle and there's problems on connectivity and the Wi-Fi?
The AI will take over.
Yeah, so if you lose connection,
Oh, okay.
then the AI takes over. And so at least you don't get like obliterated if suddenly you go in a tunnel or something. Yeah.
Since you're a player on, say, Steam in their mobile, do you have a preferred platform that they buy their coins or whatever through?
No, they can buy on any platform they want.
Like, do you get a bigger share from a certain platform, or find like advertising more for just mobile, you have more mobile users better?
I mean, it's all relatively level. KIXEYE Live, we don't share with like Facebook or anything like that, so that's the only real difference between the platforms, and that's why it exists basically, so we can control it in not just monetization ways, but in every form. Yeah, did that answer the question?
Yeah.
Yep.
Anyone else? Okay.
Cool.
Thank you very much.